Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video we are going to talk about probability, and it must be mentioned that it is only an introduction to probability. We are going to have more videos about this topic. In this video you are going to get familiar with the basic definitions that we have in this chapter, and you will be able to solve simple examples. Okay, let's start. The first definition that we have here is probability. Actually, it's value that shows the possibility of an event to happen. It's going to be a number between 0 and 1. When the probability is 0, it means it is impossible. When it is 1, it means it is definitely going to happen. For example, if the probability of having rain for tomorrow is 0, it means we are not going to have rain, and we are sure about that. And when it is 1, it means definitely we are going to have rain. And also we can show it by percentage. 0% means impossible and 100% means certain. The second definition that we have is outcome. It's a single possible result of an experiment. For example, when we roll a die, having 5 is an outcome because it is a single possible result, or having 3 will be an outcome, but having 7 is not an outcome because it's not possible. When we roll a die, the result would be 7. Or for example, when we flip a coin, having heads is an outcome, or having tails is an outcome. The third definition that we have is sample space. It means all possible outcomes, that it is a set. So, for example, when we roll a die, we show it by S. When we roll a die, the sample space will be equal to a set of 1, 2, 3, 4, 5, and 6. This is all the possible outcomes. Or for example, when we flip a coin, the sample space will be set of heads and tails. What is the definition of event? An event is any collection of outcomes from the sample space. It can be one outcome, which we call it simple event, for example, getting a heads when we flip a coin, or it can be compound event. For example, when we're rolling an even number on a die. Either even number means 2, 4, and 6. What about 8? 8 is not a possible answer when we roll a die. So it cannot be in this set. Most of the time my students have problem with specifying differences between outcome, sample space, and event. So I'm going to allocate this part of the video for differences between outcome, sample space, and event. For example, let's start with outcome. It is a single possible result of an experiment. For example, if I roll a die, 2 is an outcome because it is possible to have 2. 4 is an outcome because it's possible to have 4, but 7 is not an outcome because it is not possible. What about sample space that I show it with S? It means all the possible outcomes when I roll a die, having 1, 2, 3, 4, 5, and finally 6 is possible. So it is a set of all the possible outcomes. What about event? This is the challenging part because students cannot mention the differences between event and outcome. First of all, event can have one outcome or can have more than one outcome. And the main difference between event and outcome is event is outcomes that we are interested in. We want them to happen, okay? It is a specific outcome that we want it to happen. For example, when I roll a die, I want the answer to be 2, or I want the answer to be 4. Or, for example, when I roll a die, I want the answer to be odd. It's going to be a set and it's going to be 1, 3, and 5. It cannot be 7. Why? Despite the fact that 7 is an odd number, because it is not possible when we roll a die to have 7. So 7 cannot be in this set. Here we are going to talk about formula probability. It's really easy and probably you can guess that. We show it by P. I'm sorry, this must be U. It is number of favorable outcomes divided by number of possible outcomes. If this formula is confusing and challenging, don't worry, we are going to learn that through examples as always. The first example that we have, find each probability for one roll of a number cube or die. Okay, we want to calculate P of odd number. First of all, inside the parentheses shows event. It means results that we are interested in, that we want them to happen. Always start with writing sample space. So when we roll a die, what is the possible outcome? It can be 1, 2, 3, 4, 5, and 6. Please follow this strategy. I know that this question may be easy, but we are solving easy examples. In future, you are not going to have easy examples, so following these steps are necessary. Always start with writing sample space. Now specify how many odd numbers do we have in sample space. 1, 2, I'm sorry, I'm specifying even numbers. Let me erase the board. Now specify how many odd numbers do you have in sample space. 1, 2, 3. So P will be equal to number of favorable outcomes that I have circle around them. 1, 2, 3. So I have 3 favorable outcomes divided by number of all the possible outcomes. It means number of members of sample space. 1, 2, 3, 4, 5, 6. 3 over 6. I can simplify that and the answer will be 1 over 2. Again, we have P of 2. It means when we have 2, it is favorable outcome. Again, I'm starting with writing sample space. 1, 2, 3, 4, 5, and 6 are the possible outcomes. Which one is favorable? This one. So P is equal to number of favorable outcomes. I have only one here. 1, number of possible outcomes. 1, 2, 3, 4, 5, 6. 1 over 6 is the only correct answer of this example. Again, I'm starting with writing sample space. 1, 2, 3, 4, 5, and 6. We want to calculate P of 5 or 6. It means when it is 5 or when it is 6, it is desirable. So these are the favorable outcomes. Again, P is equal to number of favorable outcomes. I have 2 here, divided by all the possible outcomes, which are 6, and I can simplify it, and the answer will be 1 over 3. P of greater than 2. Again, I'm going to write the sample space. 1, 2, 3, 4, 5, and 6. Okay, which outcomes are greater than 2? 1, 2, 3, and 4. So these 4 outcomes are greater than 2. P is equal to number of favorable outcomes, which is 4, divided by number of all possible outcomes, which is 6. 1, 2, 3, 4, 5, and 6. I can simplify it, and the answer will be 2 over 3. Okay. Again, I'm going to write sample space. 1, 2, 3, 4, 5, and 6. I want to calculate P of less than 7, so I must specify outcomes that they are less than 7. Of course, 1 is less than 7, 2 is less than 7, 3 is less than 7, 4, 5, and 6 is less than 7. So P is equal to number of favorable outcomes, which are 6, divided by number of all the outcomes, all the possible outcomes, which is 6. It's going to be 1. It means definitely we are going to have less than 7, and it's obvious when you roll the die. Of course, the result will be always less than 7. Here we have P of 7. As I told you, always start with writing sample space, the set of sample space. 1, 2, 3, 4, 5, and 6. Okay, I want to have 7. I want the result to be 7. Look at the sample space. Do I have any 7? No. So having 7 is not a possible answer. So P will be equal to how many favorable outcomes do I have? Did I draw a circle around any of members of sample space? No. So 0. Favorable outcome divided by 6, it means it is going to be 0. And it is really obvious when you roll a die, it's not possible to have 7. So it is impossible, and the probability is going to be 0. Okay, here we have another type of example. We want to find the probability for selecting a letter at random from the word Arkansas. What was the method? What was the strategy? Always start from writing the set of sample space. When we choose a letter, it can be any letter from this word. So each letter will be a member of sample space. So A, R, K, A, N, S, A, and S. I want to calculate probability of having A. So when I have A, it is favorable outcomes. So let's specify A's. I have 1, 2, and 3. So P will be equal to number of favorable outcomes. I have 3. Divided by number of all the possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3 over 8. And this is the only correct answer of this example. P of P. Again, I'm going to write the sample space. A, R, K, A, N, S, A, and of course S. I want to calculate P of B. It means I want the answer to be B. Can you see any B in the sample space? No. So probability, number of favorable outcome. Do I have any favorable outcome in the sample space? No, so it's going to be 0. And the number of possible outcomes is 8, so it's going to be 0. It means it is impossible. We want to calculate P of vowel. Always start with writing the sample space. A, R, K, A, N, S, A, and S. Okay, let's specify members which are vowel in the sample space. I have 1, 2, and 3. So P of vowel will be equal to number of favorable outcomes, 1, 2, 3, divided by number of all the possible outcomes, which I have 8. It is going to be 3 over 8. P of K or N, again write the sample space. It is necessary to write because it's going to help you, otherwise the possibility of making mistake is really high. I want the result to be K or N. So this one is favorable outcome and this one is favorable outcome as well. So P is equal to, how many favorable outcomes do I have? 1, 2. And how many possible outcomes do I have? Number of members of sample space, it's going to be 8. 2 over 8. I can simplify that and write 1 over 4. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.